그러면 이불 끌 수 있나 이쪽은? Okay, so we start. Are you ready? So this is maybe the last class in this week. So you may be very excited to have a good Friday evening. So this class is E405, Electronics Design Lab. So the title is AI for Robot Intelligence, Perception, Planning and Control. So this may be the second week. I'll provide the ROS tutorial. I'm Prof. Myung from Urban Robotics Lab at the School of Electrical Engineering. And nice to meet you. So you have to be familiar with ROS, Robot Operating System, to have some experimentation with the robot the class provides. So you guys already have the robot or not yet? Not distributed yet. So it may be available later on, so you don't have to worry about that. So to program something on the real hardware, real robot, you have to be familiar with ROS, because all the protocols you write down through the code should be standardized in the format that is compatible with the ROS, because ROS is the middleware that is already installed in your own hardware, the robot. So this ROS provides libraries and tools to help software developers create robot applications. So you don't have to think about the communication problem. You don't have to think about some how to get images, how to get sounds. You don't have to worry about that. Yeah, already provided as an API in the ROS standard. So it provides hardware abstraction, device drivers, libraries, visualizers, message passing, and packet management, and more. So even though you are not familiar with the TCP communication, then you don't have to worry about that. Everything is already implemented in ROS, and you only have to use that. And the most important thing is ROS is licensed under an open source BSD license, Berkeley Software Distribution License. That means you are free to distribute your own code. And also you don't have to also disclose all your code, because this is the BSD license. Or it's very similar to MIT license, and there are several kinds of licenses like the GPL, GNU public license. So in that GNU public license, GPL, if you are using some open source, and based on that, if you are coding something in addition to that, then you have to open your code to the public. That's the obligation from the GPL license. But BSD, MIT, you don't have to do that. Yeah. If you correct something based on the open source, you don't have to open your source to the public. So that's the big difference. So if you want to commercialize your own code, then it is quite good if you use this BSD or MIT, because you don't have to release your own source code. But if you are based on GPL, then you have to open your source code that it actually can shrink your product, and also sometimes some damages from outside. So this is the big advantage, BSD license. So you can see some of the other middlewares, like now they are actually closed source. So you don't have the source code for here. And some Operos, this was developed from Korea, but unfortunately, this is Galapagos. No one uses this Operos nowadays. RT, very similar. So they were developed for this kind of middleware for the robotics society, but no one uses this one nowadays. But ROS is actively used by many companies and institutes and universities. So you can see some of the differences. And also, the ROS can be operated on various platforms, OS platforms like Windows, Linux, macOS X. So you can use any kind of operating systems. And based on that, you can install this ROS, and this is some kind of middleware, and you can design your own application. And ROS acts as the plumbing because it can connect all the processes. So process management is quite easy. Inter-process communication is quite easy. Device drivers are also provided in most of the cases, so you don't have to care about these device drivers. And tools, there are many tools available. So they also provide the simulation tools like Gazebo, visualization tools like Gazebo and RVs, and graphical user interface. So you can use RVs and data logging. So ROSBag is provided for logging the data. So you can use various tools if you are installing the ROS. And also it provides a lot of capabilities like control, planning, perception. Actually, they are the three most important aspects in the robot operation. We first use the sensors to perceive from the environment, and then you plan something based on the sensory input, and then based on that you can control the actuators. So there are three important steps. So we can deal with these three steps using this ROS. And also mapping of the environment is possible by this ROS, and manipulation is also possible. They are intrinsically provided from the ROS packages. And ecosystem, package organization is quite easy, and software distribution is also quite easy because we can use this ROS.org. There are plenty of source codes available in this ROS.org. Documentation available, and also they provide a lot of tutorials. ROS philosophy. So peer-to-peer communication. Individual programs communicate over defined APIs, like using the ROS messages. We'll discuss about that in the later slide. And also they provide the services, so we'll also discuss that later. And also they provide the distributed way to program. Programs can be run on multiple computers and communicate over the network. So if you run multiple robots, then they can easily communicate with each other. So it is another big advantage. And multilingual, ROS modules can be written in any type of languages like the C++, Python, MATLAB, Java, and so on. And also lightweight, standalone libraries are wrapped around within a thin ROS layer. So it is quite portable. So you can even install your ROS environment to very small hardware like Raspberry Pi. And also it can be, you can run your own application above this ROS. And free and open source. Most ROS software is open source and free to use. So the ROS actually started from 2007 from Stanford AI Lab. The initial name was C-Sharp. It started from there, and after that, the company called Willow Garage actually maintained this ROS, and the name ROS appeared from here, Robot Operating System. And ROS 1.0 appeared in 2010, and then after this initial ROS, there appears a lot of different versions. You can see some rules like this: B, C, D, E, F, G, H, I, J, K, L, N. Yeah. So likewise, they named different ROS versions like that: box turtle, sea turtle, diamondback, and so on. And nowadays we can see this noetic version in 2020, and also ROS 2 was released from 2017. So nowadays, most of the developers are transferring from ROS to ROS 2, ROS 1 to ROS 2. Yeah. So, and some libraries are not supported anymore. So ROS support will be deprecated later on, and most of the developers should also move to the ROS 2 in that region. And LTS, the long-term support version, and there is also the support period actually for this LTS version. So this is a stable version, so you can use this one stably, but maybe around 3 years it will be terminated. And also starting from 2013, this version was maintained by OSRF, Open Source Robotics Foundation. So maintenance company has been moved from here to some foundation. Yeah. So nowadays, OSRF maintains these ROS versions. You can see some cheat sheet of the ROS. So there are some commands available. So you have to be familiar with this one. So some of them, ROS core. So this initiates the master in the ROS. So if you are using ROS 1, then you have to execute this command once, yeah, ROS core. Then the master appears and everything is maintained by this master. And ROS message, ROS RV, so they, ROS service, so they display message service data, and also so you can use different usages of this ROS message and ROS service. And ROS run will run the package, and among the package you can find some executables in there. That means we have some node here. Node is the execution file actually. So you can run this node using this ROS run. So ROS run, turtle sim, this is the package name, and inside the package there are a lot of nodes, a lot of execution files. So among them, we run turtle sim node, turtle sim underbar node. So we can run this node using this command, ROS run. And actually, this is the command for ROS 1. So if you are using ROS 2, then it may be something different. In ROS 2, they use, instead of ROS run, they use ROS 2 space run. Yeah, ROS 2 space run. It is something different, but very, very similar. And ROS core is not available in ROS 2. In ROS 2, it is quite distributed and you don't need the master anymore. So master will be deprecated, and just initiating this node, you can run the communication between the nodes. And ROS node, so you can invoke some node by using this, and also list the node using this, and also kill the node using this. And ROS launch. So starts ROS nodes locally and remotely, as well as setting parameters on the parameter server. So in the ROS launch, this is some kind of batch file. So you run something at the same time. In the .launch file, there are some descriptions of how to run the ROS node. So using this one, you can run the multiple nodes at the same time. And ROS topic, so topics are displayed and listed and so on. And also ROS parameter, you can set some parameter, work as some parameter using this ROS param. And ROS service, you can also list the ROS service and also print the name of the node of the ROS service and so on. And ROS spec is quite useful. You can save all the data, all the topics, or all the messages. You can save all of them in the back file, BAG. So ROS spec record -A means you save all the data. And ROS spec record topic 1, topic 2. You can just save the special topic like topic 1 or topic 2 by using this command. And then later on, after saving this one, later on you can run this one using ROS spec play. ROS spec play, and this is the back file saved. So you can rerun this back file, and actually for debugging purposes it is quite useful because you can save the data and play it as time goes on, and you can debug something if something is wrong. and some graphical tools like RxGraph, and RxPlot, RxBank, RxConsole, and so on. So there are some useful comments like this, so you can refer to this cheat sheet. And you can install ROS. This is the ROS 1 version. So ROS 2 will be discussed later. So in the ROS 1, the melodic version will be discussed. So the most matching one is the Ubuntu 18.04 LTS version. So you can first use this OS, and then upon that you can install the ROS melody. So you can manually install this one. Just follow the commands, instruction in this one, or you can automate this installation. So automatic install of the ROS in just one line command. So you can use this GitHub repository. So you can use Robotis. Robotis is the Korean company. So they provide some GitHub. So you can get this code actually install ros_melody.sh shell command is compiled in here. So you can just download here and then change the mode to 755. That means it is executable. It is made executable. And then run this shell command by running this one. /install ros_melody.sh. Then you run this one because it is already changed to executable file. And then bash this one. Bashing this one means if there are some commands available inside here, it will be sourced. So these commands will be executed sequentially, and finally you can get the ROS melody on your Ubuntu version. And also you can set up some ROS environment by referring to this website. And in short, it is like this, setting up the ROS environment. You can edit this file, .bashrc file. So inside here, you can see a lot of aliases and the source like this and export like this. Aliasing means if you just type in EB, then it means editing this bashrc file. And SB means sourcing this bashrc file. Sourcing means executing this one. And CW means change directory to Catkin workspace. Catkin workspace is the main directory it is working on. So it changes to the working directory, and CS means CD Catkin workspace source code. So if you make some source code, then you have to use CS to get there. And CM actually compiles and builds this workspace. So Catkin workspace and Catkin make will be called by utilizing the CM alias. So there are some aliasing defined like here. So sourcing this one means they are already defined in the terminal. So by just invoking those commands, you can just directly use those commands. And source, this setup bash should be sourced, and also sourced, this one, develop, setup bash. So you just follow this procedure. And also ROS master and ROS hostname should be specified. So ROS master URI. So if you just use the master in your local host, then you can just use this one, local host like this one. But if you are using master in the other IPs, then you have to specify some IPs here, different IPs. IP name should be here. And ROS host name, in this case, this is the local host. So by editing this one and sourcing this one, by just running SB, you run these commands. And then there are some important file systems in the ROS. So I have made some videos for this.
You can set the master on the remote location.
So this
Host
was
name
the
is the
pre-recorded video,
and we
so
can
we can record it.
define the arbitrary host name. After setting up this ROS environment, you can make your own package. This package is the software organization of the ROS code. This package can contain the libraries, executables, scripts, or other softwares. And this is the package.xml, and this is called the manifest file. This is the description of the package. Some dependencies between the packages and some meta information is stored in the package.xml. This is the virtual box. I have installed the virtual box, and inside the virtual box I have installed the ROS. So if you install the ROS properly, then there is the Kaist workspace folder. This is the main folder for programming the ROS software. So under there, you can see three folders: build, develop, and source. Under the source, you can see various sources like here. And I have installed these ROS programs. And under these ROS programs, there are some examples in here, and ROS tutorials topic will be used in this example. There is the source folder.
So if you download the source code, then you have to put it there.
And
Source
also,
folder.
the message file is defined here. And this is the launch file to run the package. And you can see that there's the package.xml file. And if you see the details of this package.xml, then you can see that this the name and version, description, some meta information is defined here. And some dependencies of build process. We should use process CPP, standard messages, message generation, process CPP, and so on. So in the build and in the running, this kind of dependencies are specified. And also, this is the configuration file to compile your application. CMake list.txt. So in here, you can see that some executable file is specified. This is the executable topic publisher. This is actually the execution file. And using this CPP file, you can compile and build this CPP file, and the final execution file is this one. And it shows the dependencies. And another executable file built from the source topic subscribe.cpp.
So you can see that in this CMake list.txt, there are some instructions for how to build this executable from the source code. So they are specified like this, so you can just follow this format.
This topic subscriber execution file is also specified. So we have two nodes actually, publisher and subscriber nodes. By building this project, we can create these two execution files, one of those.
And this page,
Okay. So the Kaist package must contain the Kaist compliant package.xml file, as we already seen from the previous video, and also must contain the CMake list.txt, which uses Kaist compiler. And each package must have its own folder. So if you have some packages like here, in each package you can see that there are CMake list.txt, how to compile that, and also package.xml, configuration file, manifest file. So each package will have its own, these two files. And also, before understanding the topics, you have to be familiar with the graph concept. Actually, first we have to initiate this method. This is name service for rows. So it will help the nodes find each other. So if you do not initialize this method, then they cannot communicate with each other. And nodes, this is the executable that uses rows to communicate with other rows. And messages, this is the data type used when subscribing or publishing to a topic. So you have the topic, and through this topic you can pass the messages. And topic is the nodes can publish messages to a topic as well as subscribe to topic to receive the messages. You can see some diagram later on. And rows out, this is the rows equivalent of standard out and standard error. So you print out something, row score. If you just initiate this row score, then it will initiate the master, and the rows out will be also executed, and the parameter server will be also executed. And rows master manages the communication between the nodes, and every node registers a startup with the master. So we run the master with the row score. So let me show the video also. Has been already. So rows master, it manages the communication between the nodes, and these nodes are actually the executable file. And each node registers a startup with the master. So you should start the master with a row score. So I'll launch the row score at first. So I have installed the rows, so you can see is some terminals in here. So I have used the terminator terminal, and I can type in row score in here. Then this row score is executed, and this is established. The rows master has been established. And there should be some nodes. So this is the single purpose executable program, and this should be individually compiled, executed, and managed. And this is usually organized in packages. So we can run the node with this command, rows run, and specify the package name and the node name. And if you want to see the active node list, then you can use this rows node list. And you can retrieve some information about the node with the rows node, info, and node name. Okay? So if you run multiple nodes like this, then it is automatically registered to the rows master when it is initiated. And then these nodes will communicate over the topics. So we will discuss about the concept of the topics. And nodes can publish or subscribe to a topic. So some nodes can provide information using the publish function, and the other node can subscribe to this topic and to get some information from other node. So typically there is one publisher and n subscribers. So we have multiple subscribers that receives the information from other publishers. And topic is the name for a stream of messages. So the messages will send out and can be received through this topic. And we can list active topics with the last topic list, and subscribe and print the contents of topic with last topic echo topic. And we can also show the information about the topic with the last topic info topic. Okay, and okay. So we have done that. So ROS messages are the data structure defining the type of the topic. So you can see that this is defined by the file specified by .msg. So inside this file, you can see some specifications like this, data type and the actual data name. So comprised of a nested structure of integers, floats, booleans, strings, and so on. And also you can set the arrays of the objects. They are defined in this MSG file. And you can see the type of the topic by using ROS topic, type, and specific topic name. And publish a message to a topic by using this. You can use pub, ROS topic, pub, then publish to this topic something. Some messages can be specified here, some data, type, and actual data. So for example, integer number can be specified, integer number. Then you can publish this integer type of number to the ROS network. Then if the other node subscribes to this topic, then they can receive this kind of messages. So you can see some example of this one.
So we will have a very simple example. We first ran ROS core previously, and I'll use the ROS learn, and this is the package name, turtle sim. This is the simulation of the turtle board, and turtle sim node. This is the actual node implementing this turtle simulation. And then we will quickly operate this turtle using the key. So this is the node name for providing such kind of functionality. So turtle tally of key will be used to manipulate the movement of this turtle. And we can also graphically visualize the relationships between the nodes. So if you use RQT graph, then you can see those kind of relationships like this. So this circular one means the actual node. So there are two nodes in here, tally of turtle and turtle sim. There are two nodes, and there's one topic called the turtle one underbar command velocity. So this command velocity is actually the tally-operated command, tally-operated messaging to the turtle sim. So this tally of turtle will send out this message to the turtle sim. Okay, we can see how it works. So at first, I'll just copy this. ROS learn, turtle sim node to here.
So you have to use different window because they are threaded, and you run this one node here, the other node here, and so on. So you have to provide multiple windows.
And also, I'll copy this tally operation node. Use arrow keys to move the turtle. So if I use the arrow key, like going forward, and it goes forward. Turning left, it turns left, and going forward. Turn left, going forward, forward, left, forward, left, forward, and so on.
Be sure that
So I can use
your keyboard should be focused on this window because it is inputting some command.
Command velocity. So if you want to see the topic, we can see the topic in here, show information about the topic. I can just copy and see the topic. So I'll just copy here. The name of the topic here is what? Turtle 1 command velocity. So before having that, I'll use RQT graph. So you can comment like Ross learn RQT graph, or simply you can learn RQT graph. So this is the abbreviation for this comment. So I'll just call this RQT graph, then it appears that we have this topic. So I'll use this one, info to one command velocity. This shows the information about this command velocity, and if you wanna print the contents, and I can use this one also. Echo. So if I comment the total,
So characters are so small. So if you have some command velocity here, then it will appear like here.
going forward, you can see that linear velocity and angular velocity appears here. So
Linear,
this is the
angular appears
content
here.
of topic. So I can command it to going to the right, and you can see that the angular velocity appears here. The linear velocity is here. And if I command it to go forward, then you can see that only the linear velocity appears here. Okay? So you can confirm that this graph, RQT graph, visualizes the relationship between the nodes and also visualize the topic.
So after doing that, we can move to ROS service. So previously it was ROS topic, but ROS service is somewhat different. Can easily attach to ROS client service framework. So it works as the client and service framework. So that means in the ROS topic, you publish the topic to the air, for example, and every node can subscribe to this one and get the information from that. But in the service client, you just have the one connection, not the multiple connections. So ROS service has many commands that can be used on topics. Like this is very similar to the topic, list, call, type, find. And some ROS parameters can be set using the set parameters, set, get, load, dump, delete, that list. You can use this one to set some parameters in ROS. And also, how to create message and service. Message files are simple text files, so you can describe that, like previous example, like this one. You can just write down as a .msg file, and then ROS does the next thing. They are used to generate source code for messages in different languages. So the source code will be automatically generated for this ROS messaging. So you just have to define the .msg file, and if you make this system, make this the source code, then this source code will be automatically generated. And SLV is the service file, coupled with two files, request and the response, stored in the MSG directory of the package, and service files are stored on the SRV, service directory. You already have seen that. So actual example.
And the second example is to use the messaging to generate, enable this, the source code here. Then there are three folders in here. One is the messaging folder, and source folder, and the ROS folder. And under the source folder, we can program your own code. So topic publisher.cpp or topic subscriber.cpp files are in here. Let me elaborate on this later on. And under the MSG folder, you can see there is the MSG tutorial.msg file. If I double click here, then you can see the content here. Yeah, very simple. Time stamp into 32 data. So stamp is the data with the type time. And the data is in the type of integer 32-bit. So this is very simple type and the data structure. So it is stored under the MSG file. Then compiling this source code, you can see that the header file for indicating this message will be automatically generated. So these messages are just simple text file with a field type and a field name per line. So you can create a package. You can use CS. CS moves you to the Kekin and Kekin workspace and the source. Now this is the CS. We have defined the alias in the previous lecture. You can see that. If you have the command CS, then it is alias to like this. You will be moved to Kekin workspace and source folder. If you have the CW, then it moves you to Kekin workspace. And if you command CM, then it is moving you to the Kekin workspace and compile some sources in there by using Kekin make. So we will just use this abbreviation alias. So CS will move you to the source code and Kekin create package, and we will create package using this command. And this is the package name. ROS tutorials topic. This is the package name, and message generation standard messages ROS CPP are the needed libraries to build this package. And then you can change your directory to ROS tutorials topic. It is automatically generated. So in there, ROS tutorials topic, in there you can see that there can be the include file or the source file. So if you compile that, then you can see that this CMake released file should be speech file. So in there you can see that execution file can be built. Topic publisher node can be built using the source topic publisher.cpp. And the topic subscriber node will be built based on this CPP file. Source topic subscriber.cpp file. So you should speech file like this way, CMake this. And then package file is the package configuration file we have discussed in the previous lecture. And Kekin is the build system, is the ROS build system to generate executables, libraries, and interfaces. And you can use the CM. This is the abbreviation for Kekin make. So you can change your directory to Kekin workspace and then use CM. Actually, this CM was defined to do these two commands at the same time. So you can just use CM to move you to the workspace and compile and build them. And whenever you build a new package, you can update your environment by using this. By sourcing develop setup.bash or ROSpec profile, then you can have updated package links, so that the ROS can know where your package is located.
So this is necessary because under the source there are so many packages. Yeah? There can be so many packages. So you can compile the packages at once by performing this ROSpec profile. after building your own packaging. Okay, and so in the Kekin workspace, under the folder, we have the source, build, and develop. So you have 3 folders, and you don't have to touch the build and develop folders. So they are automatically handled by the ROS. So you only have to modify the source folder. You can clone, create, and edit source code in this folder. And after invoking CM, you can make some binary files, and the target will be placed inside this develop folder. And if you want to clean up the build and develop space, then you can use Kekin clean to clean up the build and develop.
So space is source with the packages, for example, using the topic, publisher, and subscriber. So you can download the source code in here, GitHub, robotics git, ROS tutorials, tree, master, ROS tutorials topic. In there's the source code, so I'll use this. The first one is equivalent to CS, and then git clone. This source code will be cloned, and then CM. Then these 2 nodes will be automatically compiled and built. And then I'll run this command, 2 commands. ROS run, ROS tutorials topic, topic publisher.
So the 2 nodes are executed by using this command.
Let me first kill out all the processes. So I can just kill. By having Ctrl+C, you can kill the processes. Only the ROS core will be remaining. And I can put ROS run, ROS tutorials topic publisher. So if I run this one, then the topic will be published. So info, time, and send message will be published like this. And also you can use this one to subscribe the topic. So I will use this one on the right side. So I'll rerun. Topic publisher at first, and also topic subscriber should be used. I will copy wrongly. Subscriber will be called in here. Subscriber. So if I run the subscriber, then you can see that it is echoed. The published topic will be echoed in here. The timestamp and the received message will be displayed. So they are coinciding with each other. Okay? So the content of this topic publisher.cpp will be shown in here. And you can also see the actual code.
So this video will be uploaded on the KLMS later on, so you can revisit this website and see the details. I'm sorry,
you have
the characters are so small.
So if I double click this one, then the editor will appear here. So this is written in Korean, so I'll use the English version here. Shop include ROS.h. This is the default header file. And shop include ROS tutorials topic, message tutorials.h. We have not actually made this header file. This header file will be automatically created and built into packaging. And this name should actually correspond to the message file. So under the message folder, we have the message tutorials.msg. So this should be the name of the header file, msg tutorial. So that's why I have put the msg tutorial.h in here. And in the main, we initialize the node. So the name is specified here, topic publisher. And we should create the node handle. Node handle for communication with the loss system. Using the node handle, we will publish and also subscribe the topic. And then we will declare the publisher, create the publisher ROS tutorial Prof using the message tutorial messaging from the ROS tutorial topic page. And the topic name is ROS tutorial